Thank you all for joining us in this expert panel discussion titled Evolving Critical Systems with gRPC Bidirectional Streaming. What works, what hurts, and what's next? At Mastercard, we are the financial backbone of 200 and more countries and their 150 currencies, often moving money at lightning speed. I'm Prasanna Srinivasan, a director of software engineering at Mastercard. My team and I, we focus on event-driven architecture and deliver it at scale. And in the center of it is gRPC. And today I have the pleasure of sharing the stage with our esteemed engineers from Mastercard who have been nurturing it, running it for several decades, starting with Ravi Cherukuru, our payments architect, Thiyagarajan Velappan, our developer productivity architect, Zhang, our all-rounder distinguished engineer, and Eric Robbins, our security architect. So just for our audience to get an idea of what we do in Mastercard, these are official numbers from 2024, the number of currencies, the number of cards in circulation, and the number of transactions that are processed. That's 159.4 billion with a B processed in the year of 2024. So today's session, we have broken this conversation into three pieces. What works, and then we go into what hurts, and then we go into the what's next. We have curated these questions for consistency, and we'll run this for 20-25 minutes. And then we'll open this floor for questions, Q&As. Okay. So I'll start the conversation with the what works, and I'll join the team. So just setting up the slide for the conversation. So I'll start with what works. So Ravi, if you can paint a picture on how our tech stack at Payment Networks or the payment system is, and what is our intention in going towards gRPC streaming?
Sure, Prasanna. Can you all hear me? Yep. Thank you. Mastercard is a technology company. We manage a global network to process financial transactions, services, and data to move across the geographic regions. And we process these payment transactions across the geographic location with very high volume, high throughput, with low latency, at scale, with security embedded in it. We kind of built our tech stack with a lot of customization to move this, the low latency data across the globe, all the way from one continent to other continent. We have customized it by using these bidirectional protocols, but what's next? How can we build the scalable payment network across the globe, right? That's where we came across gRPC about 5 years ago. Ever since, we kind of evolved and built our Mastercard tech stack, event-driven architecture around the gRPC protocol, because it provides security, it provides a developer experience, and faster delivery. And now we process hundreds of millions of transactions every day throughout the globe at lightning speed. That's how we evolved the Mastercard network.
Yeah. Thank you so much, Ravi. That sets the stage. And for our audience here, hopefully you're able to see the screen. This is our global backbone. Let me see if I can move it a little bit up. Showing where we run, where the global network, the network backbone, the data centers, and the public and the private cloud integrations across the globe. Always up and running, live, and pushing through a huge volume of TPS or transactions that Ravi was mentioning. So let's move on. So from a developer productivity, tools, and enablement, why gRPC and why gRPC streaming? Thia, if you can.
That's a good question, an important question. Hope you all can hear me okay. When we were evaluating technologies to modernize our critical systems, gRPC obviously stood as a foundational building block, mainly due to its alignment with our core technology principles, which are security, obviously, performance, developer productivity, and edge integration, to name a few. When it comes to developer productivity, I think you all understand protobuf, code gen, strong tight APIs, clear contract, multi-language support, all contributed to adapt gRPC at scale by our polyglot developer ecosystem. But what really influenced us was edge integration. We have, unlike the traditional system that Ravi was pointing to, gRPC gives clear semantics over HTTP2 that enables us to expose our APIs over trusted boundaries with fine-grained access control. And this was a huge leap for us to build secure and externally accessible services without much of protocol baggage. Another factor which is important is we call them fintech factor. Imagine you tap your phone trying to check out at a merchant store. Instantly, flurry of messages flow between the merchant, the banks, the payment network. These are all the entities that the transactions need to go to verify your identity, check the balance, confirm the transaction, all in real time. So this seamless asynchronous flow of continuous transactions makes bidirectional stream an ideal choice for high throughput, low latency, and event-driven architectures. And that too, with minimal overhead, we are able to, well, gRPC bidirectional stream was able to provide superior scalability and performance in comparison to REST or WebSockets. So in fintech, performance isn't a luxury. It is a necessity. Every byte, every millisecond count that determine the cost and efficiency of the transaction. So security, performance, scalability, minimal overhead are the things our customers absolutely value the most. So gRPC seamlessly aligns with these principles. At the same time, delivering the performance we need and without adding too much of boilerplate code. It avoided, in fact, a lot of boilerplate code and improving developer productivity. So gRPC wasn't just a protocol choice, it enabled us to rethink how we build and expose services that aligns with the core technology principles. Back to you, Prasanna.
Amazing, amazing. At the crux of it, it has to support our customers, the promise of payments, and you nailed on those developer productivity and the benefits that we got. Now let's look into scalability and observability. Jenny, if you can touch on those topics and how our driver to get to gRPC streaming from that aspect.
Sure. So when we started this journey a couple of years ago, I think this is like Ravi was talking about 5 years ago we started, and there's a lot of learning behind it. Observability, generally speaking, it's in the development cycle. It's always kind of last thing. A lot of times you only think about it afterwards. You're trying to get the things working. But at the end, we learned a huge lesson with the lack of observability and talking about how we improve it. So as Gina was talking about this morning, the gRPC protocol is a multi-layer networking protocol. So what that means is that at the bottom layer, you got a TCP, IP, all these layers 3, layer 4, the traffic going back and forth. On top, you got the, the streaming, right? HTTP2 streaming, and of course, there's the application layer, which is the true message. So when you look at this diagram, the message we're sending the message across the globe. And how do you keep the connections? Especially, we're talking about persistent bidirectional connections. And how do you report or if something goes wrong? So networking is constantly give us a lot of challenges. When that happens, how do you stop bleeding? How do you either you get yourself out of it, or you can try to route traffic to somewhere else. So this is exactly what we're trying to do this is what we call observability. We spent the huge investment on the telemetries and in trying to build into every single layer, TCP, HTTP2, and then even on top of the streaming and application. And what is really interesting is when you talk about client client and server. You have to look at the traffic on both. When you talk about, the bidirectional communication, either side is having the problems, not going to make this transaction successful. So how do you alert yourself? How do you get yourself, identified with some sort of the problems in the middle? I think that this is really where we spend lots of time and put a lot of, the detailed tracing, in every single transaction. Now, we're talking about scalability, and this is where when you have the traffic going across multiple regions, how are you going to be able to scale yourself at the time? And the traditional thinking of, how do we scale the instances, and how do we enable us to be able to, to get more traffic and scale ourselves across regions? That doesn't really work in the gRPC world, because the gRPC is all persistent connections. So when it comes down to that, we really need a different kind of the strategies to do the horizontal, the scalability, and we need to look at what is available, what things that we can get the traffic through. So we literally have to generate different strategy to control all of that. So that's kind of the big lessons that we have learned over the years.
Amazing, amazing. Thank you so much. Persistent connections. That's where it starts, and then we think and build on top of the scalability and observability there. So now let's touch on security. So what are some of the considerations from a security aspect when it comes to the gRPC streaming? Eric?
Yeah, sure. Quick show of hands. Raise your hand if you work in a cybersecurity position at your company, so I know who I'm talking to. No hands. Okay. Raise your hand if you, I see one. Raise your hand if you work for a company whose data is regulated by a government or by a customer. Okay, so we have some, yeah, all right, there we go. So I think you guys understand that, right? Mastercard is a heavy regulated company, right? We're in the payments industry. So when you introduce a new protocol like gRPC, you have to make sure it aligns with your current security standards. So regulations, laws, and your customers drive mandates. Those mandates drive directives, which in turn drive policies, which come down to standards, and finally to technical controls. So we have a whole slew of those, right, to make sure that we're protecting the confidentiality and integrity of our data. We have to, right? So when you bring a new protocol like gRPC in, you have to ask the question, do we have any gaps in those controls? So to answer that question, we actually had to tear the whole protocol apart, all the way down to the network layers 3 and 4, walk through it with tools like Wireshark to see how it worked, to make sure that we didn't have a gap. In a second, I'll explain that in detail. Okay?
Amazing, amazing. Thank you so much. So, but this conversation seems like it's a happy marriage. Whatever we wanted in our modernization journey, gRPC streaming provided everything. Was that true? We'll explore the second phase, which is what hurts, right? What were the pain points? Specifically on bidirectional streaming, which is vital for the payments ecosystem, as we mentioned. So let's start with Eric. Yeah, so from a gap perspective, on the security considerations, as you are touching with the requirements, can you please highlight to our audience what were some of the gaps from a bidirectional streaming? Yeah.
There's the biggest single one was Mastercard was shifting in a security paradigm from stateless APIs, REST-based over HTTP 1.1, to a protocol that keeps connection-based state between clients and servers. Okay, so to understand why that might be a concern, let's walk through REST first to understand. I think most of you probably here understand how REST APIs work, but in an API, almost always over REST, it's going to be stateless. Okay, so you have a client that calls a server, the client authenticates, the server will authorize the client once they know the client's identity, the request comes through, the request is granted, the response is given, and the connection closes. Very inefficient. In fact, that's why gRPC is here, right? Because HTTP 1.1 gRPC is connection heavy and inefficient, right? So, but every single time the request comes in, even though it's stateless, when it crosses our network boundary, we always have to authenticate them and then authorize them, okay, to make sure we know who they are. It's payment data, okay? Well, even if you have a session-oriented relationship, think like a web application now. So now you're on a web application, you log in, you might hit ID password, maybe use a third-party federated identity login, whatever it is. You'll then be given an authorization grant. Think about, for example, like a cookie or a JWT, all right? Every single time the request from the client then comes to the server, even though you have an established connection, you're still given an authorization grant that we can check it and say, yes, that still is John Doe on the other line. Allow the request to come through, grant the response to come back, okay, until the connection's closed. Well, those types of relationships are pretty much agnostic to the underlying network. They don't really care. Okay, if the network connection closes on a web application, the TLS session will close, and then of course you'll be cut off. And if your server's developed correctly, you'll invalidate the session, but not all applications do that, all right? gRPC, again, is built on top of TCP stateful connections in the HTTP2 protocol, all right? So now we had to ask the question, when you think about the way gRPC works, all right, when a client and a server establish a relationship, if you're using bidirectional streaming, at most, the client will authenticate one time. Okay, if you've played with this, you'll see that when a call credential is made, the call credential will come over, all right? If you're using a channel credential. If you're using a call credential, you'll see that come as well when RPC is opened up. But after that, the client and the servers keep talking. Okay, it's no different than if you were to call me on the phone. I say, hey, who is this? Yeah, I authenticate you, then we just start talking. We trust that the underlying phone call is secure and that no one's tampering it or modifying the connection. Well, remember, gRPC, at least in the HTTP2 world, runs on top of TCP. TCP is not a secure connection protocol, all right? You can't guarantee that with a TCP connection, a client and a server they don't have an untrusted third party in there, okay? The only way you can do that with gRPC is TLS, right? Okay, TLS cryptographically binds a client and a server. Okay, so as long as you have correct TLS in place, you're supposed to be able to trust that the client and the server that are talking there's no interruption, there's no third party, all right? Well, we can't make that assumption with a protocol that we just bring into our network, all right? So we actually tore the whole thing apart, okay? We ran Wireshark on it, and to make sure that we could guarantee that a client and a server couldn't suffer an interruption and not lose security, we stuck a TCP proxy between a client and a server that we ran in our sandbox. Okay, so we took a gRPC client, bidirectional streaming to a server, we put it in our sandbox, then we took Nginx and stuck it right in the middle. Okay, and every single time the client would make a call, we had the proxy modifying individual bytes of the TLS record. So if you know what a record looks like, you're going to have like a header, a few introductory bytes, you're going to have the main encrypted message, and you're going to have what's called a message authentication code or a MAC at the end, all right? Programmatically, we went through and modified byte by byte to see what would happen. Now, this was done in Java. Every single time we were able to confirm that both the client and the server got a notification. Because what's gRPC doing? It's running on the overlying transport layer, and you saw this morning with Gina, okay? The transport layer is built on top of TLS in this case, because we've got a connection there. And the moment the TLS throws a fatal alert, both the server and the client get notified, the TCP connection gets closed, and then we can do some error handling. We should never see that, right? So if we see that, immediately we're going to go into an investigation mode. We're going to say, hey, somebody's on our network doing something they shouldn't be doing. When we did that exercise, and we had to put this in front of our executive management, when we did that exercise and we could confirm that both the client and the server always were cryptographically bound by the TLS session, and that if any interruption occurred, the connection was closed. When it was reopened, authentication was forced. So the call credentials come through again, the channel credentials come through again, and that's what we needed. We never wanted gRPC, a final note here, gRPC tries to repair those subchannels. A channel is the virtual logical connection between you and your server. The subchannel is where the actual TCP connection is, if you're load balanced, all right? So in gRPC, if a subchannel goes south, okay, it will try to repair it and bring it back up. Well, we don't want it doing that without forcing authentication again. That's what our project proved. If you guys like that idea, we thought about bringing that back next year and actually showing you what that looked like. So we were going to put that in a sandbox and show you how we were going to monkey with the bytes. But if we have an interest, I think we'll bring it back. So anyway, there you go.
That's amazing. Amazing. That's a takeaway for the upcoming year also. That's awesome. So let's move to load balancing challenges, the mindset of load balancing and how the gRPC bidirectional streaming changed that whole plot, and what opportunities did it provide us, and how did we overcome? So Jenny?
Sure. So the load balancing actually is a very simple concept. And in the traditional architecture, the load balancers, I'm going to use F5 as an example because most people understand what that is. These kind of the load balancers are the server-side load balancers and routing the traffic at the TCP layer. So this kind of load balancer actually works really well with HTTP 1 protocols because the routing decisions made at the connection establishment. Now, switching to the gRPC world, okay? The gRPC is persisted. So once you make the connection with the backend server instances, the connection stays on. And all of the RPCs behind this, this channel actually pointing to the same backend instance. So over time, this instances may got overloaded, while some others probably say idle, because your connection just made beforehand. And when you send traffic, you have no choice. This is where you're coming from, and this is where you get to, right? So the traditional load balancers in this case, it doesn't really work well. We learn hard lessons, to be honest. And we started with that and turned out that this is truly, there's no load balancing. So this is when we decided to switch to the client-side load balancing. You're sitting all these talks. The Google team has been telling you that they're talking about client-side load balancing. There is a reason, because on the server side, it's not really having an understanding where the traffic is coming from, and especially when you make the persistent connection, there's no way you can switch. So the client-side load balancing on the other side, and you can build in all these intelligence to the clients to make it aware all of the backend available backend server instances where they are. And this is, in our case, we make all of the streams and connection initially when the client starts up, and we created, and all traffic is being sent kind of evenly across all of the streams that we have. And this is kind of the way actually we kind of switch to at end. This maybe sounds easy, but there's a lot of things happening at the client side. You would have to build the kind of the intelligent the clients, and to recognize which instances actually is available in the back, so that it can control where traffic goes. So this is truly the client-side load balancing is going to bring it to you. So when we're talking about one more thing. The regular or the traditional load balancers is more, it does not really have the visibility on the RPCs behind each of the channel. So this is another issue that we cannot do that.
Thank you, Jenny. Yeah, I think we'll, conscious of time.
We're going to run long, so
Time.
So
bear with us.
yeah, so we'll get to the customer viewpoint. How does bidirectional stream affect and concerns from a customer viewpoint? Ravi, if you can touch that.
Yeah, I will try to keep it short and simple, context of time. Like I said, we have implemented tens of gRPC APIs for our internal products and services at scale and securely. That being said, we have adapted gRPC reflectors to onboard our APIs and expose internally. But the reflectors has some challenges where it kind of exposes some internal and external methods. So we need to ensure that's properly secure your external APIs. So that's one of the challenges that we are encountering. Other things Jenny briefly touched about: load balancing, service discovery, endpoint discovery. Some of these challenges still exist. So for that reason, we are kind of adopting XDS as the protocol to do the service discovery, endpoint discovery, implement the load balancing techniques and the traffic shaping techniques. So that is coming, and we are planning to implement those XDS APIs. Once we are comfortable with XDS, and we plan to expose these APIs to the external customers. So far, we have implemented at scale and securely for most of our internal products. With that?
Yeah, thank you, Ravi. I think we can keep talking about this in length for a day, and each of them have been working on it for years. So we'll go to the what next. What do we think as we take this journey forward? What are we thinking from a perspective of? So maybe I'll start with developer productivity. From Thia, from your perspective, what's next?
Absolutely. I'm going to be brief too. So in addition to the XDS protocol that Ravi just mentioned, this will help us do service discovery and failover and automatic dynamic configuration. And we are actually coupling that with a patented adaptive request handling mechanism that actually monitors network level information about the channel health, the stream health, and so on, and will be very adaptive and scalable. At the same time, dynamically able to read out the traffic when it needed, and much better than gRPC framework could. And second, we're always on the hunt for a much lighter, faster, scalable, resilient protocol. On that front, we are exploring HTTP3 quick protocol. We have a talk, a panel session going on at this point. That will actually be helpful. It's actually built on UDP, and it is the streams are actually decoupled, and therefore it avoids some of the TCP's shortcomings, such as head of line blocking, and security is actually 0 to 1 RTT, and therefore this is going to be much faster and much more resilient to connection failures. So I'll just stop at this.
Thank you. Yeah, thank you so much.
We're going to extend you to 12:50.
Awesome.
Oh, okay.
Thank you.
I know,
Great. So we got
I know
more
you
time
guys.
for
I know you're
questions.
hungry. We'll. I promise we're going fast.
Yes.
We'll talk fast.
Yes, we'll make
thank
sure.
You, thank you so much for your patience and kindly listening to our talk here. I think we can open up for some questions. Is that good? Yeah.
All right. Feel free. Ask any questions, please.
Do you know how many APIs you have? Or in other words, do you keep an API catalog of all of the things running?
Yeah, we have tens of internal APIs.
Hold your mic up.
Sorry, we have tens of internal APIs, and they're not actually exposed today.
Like design guide? Do you have a? Oh, thank you. Google has a style guide called the AIPs, the API Improvement Proposals. Do you use those, or do you have something
No,
else?
we have a customizable internal ones. We're not using
Yet.
yet.
Yeah. It's a good information. Thank you. Yeah.
Excuse me.
I have two questions, one from a developer productivity, one from a load balancing. From a developer productivity, if you see the tech stack, in the front end, if you got Swift or whatever you got to receive your data from the user or front end apps, and then in the back end you got gRPCs, you need to do this friction point of translation of the messages or the packets. So how do you handle that for very large scale developers, okay, across thousands of developers? That is one question. From a load balancing, typically in cloud, right, you got 3 node or 5 node clusters across multiple subnets or multiple geographical regions and whatnot. So when you're doing this streaming, right, are you doing this load balancing on a message basis or on a channel session basis when you want to switch from one subnet to another subnet, or how do you go about doing that?
Yeah. Great questions.
I'll start with the developer productivity question. So there are two things we mentioned. One is strong typed APIs and clear contract. These are fundamental for scalability, especially for developers to adapt. So that's the first thing we did. Even before adapting gRPC, we got together and said, this is the standard. This is protobuf is the standard. Even without gRPC, you could use protobuf. So that was the standard that we agreed upon, and we had a central repository, just like Buff, for example, where all these schemas for protobufs are managed. So that's the first thing. And clear contract that will actually help identify issues early in the development lifecycle and reduce ambiguities. So these are the principles we adhere to for a developer productivity standpoint.
Yeah, and to add to that, yes, to your point, there are protocol remediation layers that are required. And yes, they are there. They are governed by the SLOs, and we have fine-tuned those lower level TCP layers and the gRPC.
Web app or from my iPhone app, when I get the data from the user apps back to my gRPC clients, I still need there is a friction point for the developers to do this protocol translation. Right?
Yeah. Yes.
Yeah, we're not there yet for the UI. This is all APIs,
Distributed
backend
system
APIs.
processing. Yes.
Yeah, and ISO standards basically run on these protobufs. Yeah.
Yeah, I'll quickly add to that. We didn't get a chance to finish up the content we have because we know you guys are about to chew your arms off, but there's a limit to where we use gRPC based on certain concerns about exposing it to the internet. So when you think about the standard, like a user talking to it, this is service to service, what we call trusted clients. Okay, that makes sense.
Yeah.
All right, let me go over the the load balancer. So as I mentioned, we move towards the client-side load balancing. So all of the intelligence is happening at the client side. So when you're talking about multiple, the subnets in different regions, it doesn't really matter. So we are having the connectivities getting to no matter where the what we call the gRPC servers at, and the client needs to have the connectivity to go to those servers directly. So if you have a region, so there is the smartness at the client side of it that we implemented. You can specify you want to have the percentage, different percentage, right? 90, 10, regarding to the region, right? And the client can identify what are the active streams or our active channels that we're creating and how traffic is going to be loaded towards each one of them. That's what we do.
And if I may add to what Jenny was saying, this is called per message-based load balancing.
Yes. Yes.
Yes, with a smarter selection of streams, it will know behind the scene the load and the health of the stream and the channel, and enable clients to do a more even-based load balancing, even though you're using a stream-based or RPC-based mechanism.
It's a huge mindset difference also in building.
Channel-based, you're
Yeah.
doing on a
Message.
Yes.
That's really challenging.
The channel is only the foundation, right? Once you got these channels or streams established, the message is really controlled by the client. So it'll be based on how much traffic I am getting. I can load balance through all of the available streams and channels.
I actually have a question. So, thank you so much. So you mentioned how you guys are using client-side load balancing. Where exactly are you using that? Are you using that in like internal services, or are you using it at like something like the edge? I can't imagine with like transaction processors that there's going to be a huge flood of people like submitting transactions from like a single device or something.
So great question. So the clients that we currently have is kind of internal, but it's also kind of external because that client can go anywhere. So it's that's how this payment network is really built upon. And these network connections, as Ravi mentioned, right? Currently, it's a traditional TCP connections going everywhere. So we have that network built in already. So now the client has the libraries, has the logic that does the load balancing. That client can go anywhere. It could be internal, it could be external. In fact, we use that anywhere the client is, the library is being sitting. So it's not really about where that's sitting, it's really about what it does. So the challenge with that, I can see where you're going, but eventually what's gonna happen is we need to have this kind of the client logic to be exposed with all our customers if they don't want to use the existing client that we've already have, or they would have to integrate it with our libraries in the future. So this is what the team has been working on, so that we can have the unified interface to all of our customers.
So is that for like payment processors or just individual
Yes.
people?
It is.
Yeah.
It is.
Yeah.
Plug
But
and
down the
play.
road, it can be the processors, and it also can be the individual customers. Is like modernize the customers, right? They want to build their own logic going forward. This provides the ability for
We have to be careful how much we say about our payment network. We can't,
you keep asking. I'm
if you
going to
answer the
keep
question,
asking.
we're gonna have you come work at Mastercard. We can't reveal too much about what the network looks like, but yeah, we can. In a lot of cases, we control these clients.
Right? One last
Okay.
question. Okay, one last question. Yeah, go ahead, please.
If you do per message, thank you. If you do per message, it'll be do you have to deal with a server affinity?
No, it's not. So it's the number of redundancy connections. That's what matters. So with enough redundancies built, number of connections or channels in each channel would have number of streams. Will continue to be stateless, no affinity whatsoever. And any stream can take any messages, and each message will have a unique message ID that will keep the messages apart, which message sent on which stream. So we have additional metadata to distinguish one stream from the other and one message from the other. So that's how, from an observability standpoint, we're able to track these
resiliency
messages.
through redundancy and keeping it stateless all the way through. That's how we get it there. Yeah.
I think there's going to be a mass stampede for the door here in about 30 seconds.
Thank you so much.
Can I ask you last
Hey, how about we offer this? I think we are at least 20 minutes past time. How about if some of you want to run for lunch, if you want to stay, we'll hang as long as you guys want to ask more questions.
Yeah.
Those of you who want to go eat, I don't want to get in the way and get bit. So,
Yeah.
hey, thank you all.
Thank you very
so
much.
much.
Appreciate,
Thank you
guys.
so much.
Yeah, this is biggest turnover of all.